Okay, so this month we're talking about TypeScript. So all talks that we're going to be featuring today are all going to be covering the topic TypeScript. So there'll be various talks covering different levels of TypeScript and the experiences of the people that have actually come across it and their sort of journeys with it. So let's get started. Yeah, welcome to the MMT Tech Meetup. I am the host today, and my name is Ilesh Mistry. I am a CMS specialist from MMT Digital and a content MVP, which is part of a headless CMS. You can contact me using the QR code on the right-hand side. Quick things about MMT Digital. They are part of a group which is called MSQ, and our sort of main mission is to help clients build digital products that can transform their business performance. And it's really just, you know, we're part agency, part consultancy, and really trying to be the leaders in combining technology, experience design, and lead product delivery. So if you need to contact MMT Digital, there's a QR code on the right as well. One of the things I have to put in here, it's just one of the things we have to do, but basically we are recruiting like lots of companies out there. So if you're interested in front-end roles, server-side roles, cloud systems, technical architect, and technical account lead, we have like locations in Leeds, London, Newbury, and Uppingham, but also remote abilities. So if you're interested in looking for a change of career, then please use the QR code on the right-hand side as well. A little bit about Kentico, or Kontent by Kentico. It's a headless CMS, and basically it's one that is I'm very proud of being part of, but basically it allows you to build websites and applications fast and using technologies, any technologies you want. So it's useful to know that you can use any stack that you want as well. On the right-hand side, there are a few QR codes, and in particular, if you want to get 90 days free trial, use that one there. But more importantly, like they do have a Discord channel that you can join, and all content people are available there. And just briefly, like just talking about the community out there, there's various other ways of getting involved. Like people might be aware of Hacktoberfest that started. There's also Gatsby Camp, JAMstack coming up soon as well, and next is conference, and Content Horizons as well in November. So there's lots of like different events happening. Obviously, this is probably the main event for you guys, but there's also things to join. So just a quick thing about MMT Tech Meetups. They're front-end driven. If you want to hear about more of them in the future, just follow me on LinkedIn, on Twitter. If you want to present on future ones, then again, just reach out to me. Or if you find that someone who would be a really good presenter on a specific topic, let me know as well. But just a quick, few things just quickly before we get to the main presentations, is that by all means add your questions in the chat during the presentations. We are, as you would already aware, we're recording these sessions, and if you would like to share anything on social media, then use the hashtag and other sort of like tags and Twitter handles that the individual speakers may have as well. Okay, so towards today's agenda, so what we've got today is that I'm going to be talking quickly about an introduction to TypeScript. Then we've got Alberto talking about integrating TypeScript with React. After that, we'll have Jarryd. He's going to be talking about how they've architected and built the Couchbase cloud using React and TypeScript. And then we've got Harry and Mikael talking about rebuilding their JAMstack front ends with a single library. So lots to look forward to, but let's get started. So I'm just going to end this one and bring the other slide deck across. So this presentation is going to be about a brief introduction to TypeScript, and probably some of the bits that I've actually picked up myself from just learning about it when I got introduced to it. So just quickly, if you have joined a little bit late, I am Ilesh Mistry, and I'm CMS specialist at MMT Digital and a content MVP for a headless CMS called Kontent by Kentico. If you need to contact me, you can use the QR code on the right. But what I'll be covering today, so I'm going to quickly go through a poll that I ran recently about TypeScript, and then go through some of my initial thoughts I had with TypeScript, and then go through the stuff like what is TypeScript, why you should use it, how you can get started, and then a few sort of like areas that could help you on areas to look into as well. So firstly, the poll. So I ran this poll within the actual sort of group of attendees and also outside. And for me, it was interesting to know that lots of people are doing this on their personal projects. And then it was quite important for me to kind of see that there's some people who have never used it before. And from what I know, TypeScript's been around for a while, so it's kind of interesting from these results to think, okay, maybe there are still people that are looking to try and get into it. So with that in mind, that's what kind of prompted me to kind of quickly do a quick introduction to TypeScript. But before I do that, I had some initial thoughts. So I first came across TypeScript working on Kontent. And what it allowed us to do was basically, rather than go into the CMS and create the actual individual elements manually, what we can now do, or could do when we looked at this, was the fact that you can create things by code in TypeScript. So you basically write the individual content types, which is just areas that you can populate fields, and you can write that in TypeScript and import it into your project without having to go into your CMS and do things manually. And that opens like a big thing for us in a sense of allowing us to allow developers to be a bit more adapted towards the CMS. But that was my first experience with it. And because that was my first experience with it, I was like thinking, why, because I'm just used to JavaScript, and I'm thinking, why wouldn't this pass? Like, what's going on? Like, why do I need to put a type in there? And I know that's going to be a number, so why do I need to do anything extra? So I felt I was, like it felt like a hindrance on me. But I slowly sort of like picked it up and understood the reason and why we should actually use TypeScript. So here is the next few slides. So what is TypeScript? So I'm going to take this from the website itself. So TypeScript is strongly typed programming language. Will build on top of JavaScript, giving you better tooling at any scale. And really, it's just all it really is just an additional element towards your JavaScript. The key thing here is that TypeScript can't be run on a website and JavaScript can. So what you need to do is make sure whatever you write in TypeScript needs to be converted to JavaScript. And one of the big things about TypeScript is that it ensures that you're using types on your project. So if, for example, you need to make sure that those particular properties need to be a Boolean or an array, it's important to put that in rather than almost as a developer, you know that it's going to be a number, you know that it's going to be an array, but actually having that in there allows you to make sure that you're actually making things a lot more stricter, and you follow the kind of strict formality. And it enhances your JavaScript development, really. So why should you use it? And I feel like there's a lot of reasons, and there's probably more than these as well. But TypeScript makes it more explicit, and you can be clearer on the code that you need to write. Also, it forces you to be a better coder, I feel, as well, so you can write better, cleaner, and less error-prone code, catching the errors while developing as well. And it's normally during the IDE sort of area as well. So it's, before you even decide to kind of deploy anything, you're catching some of these bugs and sort of issues. Another reason is obviously hiring developers, and if you're looking for a new role, there's always like a case of TypeScript is one of a big requirement out there as well. While you're coding, the IDE does give you coding hints and tips on the fact that if, for example, you've actually using TypeScript, then when you decide to use that particular module or function, the props are there ready with the hints to say what types they are and what they should be using. And I learned this as well, but there's minimal learning curve if you've worked with JavaScript before as well, so that's quite handy. You don't need to worry about the JavaScript file now as much as it gets converted from the TypeScript file, so that's kind of cool as well. How to get started? So the thing that you've got is that you just basically, you need to have Node installed, and then you can go ahead and then add TypeScript in using yarn or npm or other packages as well. You need to make sure that there is, you don't need to make sure, but I think it's really important to have a TypeScript config file where you can target specific versions as well. There's also things that you need to make sure you do is that you make sure that the JavaScript or TypeScript to JavaScript compiler is set up so you don't have to run the tsc command every time you kind of want to convert a TypeScript file to JavaScript. And I think also a good thing that you can do is you can use the TypeScript playground from the actual TypeScript website as well to give you a chance to kind of get started. And I would probably heavily recommend this as well is within your IDEs, get the extensions and plugins that are very much TypeScript specific. So Visual Studio Code will have a few as well. Would TypeScript prevent bugs? So this is the thing, is like TypeScript, it's one of those things that can obviously still, developers could still write invalid code. That's important to bear in mind. Like it's not going to be the case where TypeScript is going to prevent anything getting wrong. It'll certainly help, but it'll capture the bugs that would normally tend to get to production without anything failing. So it's making sure that that you've got your types in place that actually ensure that you actually are coding the right way, really. And some, additionally, you would obviously need to make sure things like unit testing are in place and other things that would help with preventing the bugs. But I feel like it's one of those ones that will definitely help, but it won't prevent all the bugs that you could have there. Where can you start using it? So I would probably recommend to start, if you've not started on this before, is smaller projects, maybe personal projects as well. Even on existing projects, you can probably look at incrementally adding those in. So, it doesn't have to be that you need to do a big bang. You can do like a slow adoption approach. Use the playground as you can to give you a helping start. And I would also try and consider things like Gatsby and Next.js, which is a lot of sort of static site generators, and even though they're doing rendering, server-side rendering as well. But those are cool and great ways to get started on this kind of stuff. And I feel that they've got great TypeScript inclusions with them as well. So they've got it like built in that you can kind of adopt those as well. And if you want, you can also utilize this on headless CMSs like Kontent, for example. They've got SDKs available for TypeScript. They've got Gatsby starter kit that also utilizes TypeScript as well. So, and we've obviously seen as well instances with Next.js as well, with content using TypeScript. So there's lots of ways that you can kind of get involved and start doing this, and it doesn't have to be on a business level. So just really finally, there's a couple of should I's. So should I really start on a small project? I think yes, of course. Like these are like a good sort of takeaways that you can probably utilize. Should you utilize or introduce this into a business and get technical decision makers to use it? I believe so, yes, because like one of the things that's kind of hard, like it depends whether you work in an agency or not, is changing the business and technical mentality to say, okay, can we introduce and use something different? And TypeScript is going to benefit the business more than, not. So I would definitely recommend that. And if you haven't learned TypeScript, then I would definitely recommend it and get it added to new projects. But the other thing as well is that, like I mentioned before, adding it to existing projects is also important as well. So try to add it in, but make sure it's incremental. And then one final point is to make sure that you are joining the TypeScript community. Really, there's lots of channels out there. There's channels on Discord as well as other places as well. So and let's help to contribute. And that's kind of it from me. Thank you. Here are contact details for me if you need to contact me, and I'll need to pause for questions if needed, but we'll go on to the next section in a bit. Does anybody have any questions? No worries if not. So what we've got next, we've got Alberto next, and he's going to be talking about TypeScript with React. So
yeah, fantastic. Thank you, Ilesh. Let me see if I can. Cool. Can you see my screen?
Yeah, we can see it.
Okay, cool, perfect. Cool, fantastic. So yeah, as Ilesh said, my presentation is going to be how to integrate TypeScript with React. First and foremost, like who am I? I'm Alberto Ferioli. I'm a senior front-end developer at MMT Digital. And here is the contact, my link for LinkedIn. If you want to connect with me after the presentation, I'm more than happy to accept all of your requests. I'd like also to thank MMT to give me the chance to have my first meetup. And let's start. So this is a quick agenda. So we're going to have a really quick intro of TypeScript. Then we're going to see where do we start from when we want to integrate TypeScript in our React project or a new project. Then I'm going to showcase some common React and TypeScript patterns commonly used, and the pros and cons of using React, in my opinion. So what is TypeScript? TypeScript is defined as a superset of JavaScript, and that means basically any JavaScript code written in a TypeScript file is valid. But TypeScript adds like a series of like API and an extra layer of feature on top of like a vanilla JS feature. So it is also an open source project developed by Microsoft, and one of the main. So yeah, why we should like use TypeScript? As anticipated by Ilesh, I think one of the main reasons is like our IDE get smarter and more intelligent. Here we can see while we are typing in development mode, we can see like some suggestions, some hint from our IDE, and this is based off like the interface we have defined above. Also, another really cool feature about TypeScript is like if we pass the wrong props in the component, we get like this red squiggly underneath the props. In this case, we are trying to pass 24 as a string and not as a number as defined in the interface here. Also, I think like self-documenting your code. So let's say, for example, we have a file like this one where we define all our interface, we export them, and we reuse those interface throughout like our code base that kind of like define and really explicitly says what like our code should do or like accept. And also like if we define the types in the parameter in our function, and also we can define the return of the type of the return type of the function. We can really create and write a really semantic code, not just for us, but also like for our colleagues. So it is a really good way to documenting your code as you write it. I want to also add this screenshot from Stack Overflow survey. I think it was 2020. We can see TypeScript is among the most popular technologies. Is ranked in the top 10, and also is one of the most loved technologies, ranked number 3. And as you can see also from the State of JavaScript survey, TypeScript is gaining a lot of like popularity over the last few years, and has like a really positive opinion from developer. So passing to like the main topic of the presentation, where do we start from if we want to use TypeScript in our existing or new application? Well, there are a few ways. I think like the simplest way and most straightforward is just like using create React app, and we need to use this flag with a TypeScript notation, and this basically will generate an application, a React application that I can where you can use a TypeScript directly, and we can gonna see like just in few seconds. Another way is when you have an existing application built with the create React app module, and you want to add TypeScript. You need to add the TypeScript, TypeScript node, TypeScript React, React DOM, and just the first script is when you use npm, and the second when we are using Jarryd. And this is basically what is going to be the difference. So on the left side, we see a vanilla JS React application. On the right, TypeScript one. There's no difference in code. In fact, the app file is exactly the same. And that's because TypeScript is a superset of JavaScript. So as we said before, any JavaScript code written in a TS file is completely fine. The only difference we can notice like the extension. So in TypeScript, when we write JS code, we use the .tsx extension. And for like a normal JavaScript file, we use the TS extension. We can also notice on the right side on the TypeScript application, we also have this tsconfig.json. This file is basically control the compiled or better like the transpiled code that basically gets transpiled in JavaScript. So in this case, you can set the target. By default, I think it's like the latest one. In this case, it's like yes 5. Also, another important one is strict. So you must basically type all the type in your application if you want like type not getting like angry at you. So I want to demonstrate how we can transform an application. I've prepared a React application beforehand, and I think is this one, and is not TypeScript at all. It's just like vanilla JavaScript. So if we add the script once as completed, the trick is basically to go here, TSX, and we should restart the server, and automatically we get this tsconfig file auto-generated, and this one is
Telefon başlığını yaptım. Müşteri sıkıntı.
Is someone muted? Okay, thank you. And we get this test config JSON file and this default setting we get. And now, like, our application is ready to accept any TypeScript value, basically. Name, string. In fact, like, we can like pass them in the component. Props, and typo here, props. Cool. And then if we want to use it, we can see our ID recognize it and we can use it straight away. Cool. So now I'd like to show you like a few common patterns we can find in a TypeScript application with the React. And I'm gonna start with the class component, even if like I think nowadays it's not used anymore class component, but maybe in some old code base you still find something related to it. So we can define our props using the type, the counter state, then we pass the counter props and counter state in the component in the generic using like this syntax. And then like we define some handler here, which like mutate the state, and of course we consume it in our JSX. I have the same exact code in a code sandbox just to demonstrate the benefit of using React. So we have the application here. I can reset. I'm basically defining like the shape of our props and the shape of our state. If we commit any silly error during development, let's say we pass a string, our IDE is going to complain, and this is because of TypeScript. And also, same thing here, we get the suggestion, and this component can also, by default can accept children, but title because we have to define it here at the top. Cool. Another simple example I want to write down was for the status function component, and this basically pretty much the same structure as the class one. We define the props, but we use this React.function component, can also be abbreviated as React.fc, and we pass the props just to make clear which props this component can take, and like when we use the component, we have to specify that props we have defined at the top. Yeah. Also, just to make clear, like when we use the component, this counter component, if we forget to pass the props, TypeScript is going to complain because the props we have defined here is mandatory, and if we want an optional props, we just need to add the question mark, and we are good to go. The last example I want to showcase is slightly different. Is when we have a use reducer, hooks use reducer. We can define the initial state. We have an action type, and in this case, we use a union type. Is basically a NOR of a JavaScript language. So we are defining that the action can have this shape with a type increment and a payload number, or a decrement type with payload number. Then we pass the action type and the initial state in the reducer, and we try the switch case with the increment and decrement, and we use the reducer in our component. Just to showcase also this snippet of code, I paste the exact same code in the playground, TypeScript playground, the one that Ilesh mentioned before. It's really useful. I would highly suggest you to play around with this tool. You can also see the transpiled code on the right side. And in here, basically, I think like we can really see the power TypeScript in this scenario. If we do a silly mistake and a typo, that's going to be catch during development and not a runtime. We can also see if we pass here the incorrect type, we do a silly mistake or typo, or we pass a string instead of a number, we get an error. And that's, I think, is really really good for the developer experience overall. Cool. I think I'm gonna conclude the presentation with my pro and cons, I would say. So as a pro, I think like having like a rich idea support is really benefit for the developer experience overall. You get auto documentation basically, but like while you're productive and writing code at the same time, you can make your code more semantic for the rest of the team and for new joiners in the team. Types make code management refactor easier and faster in the long term. On the other hand, like of course you have to write more code. Is sometimes like more verbose the code that you write. Requires compilation because as we have seen, like we have this tsconfig file that basically needs to make the rule to transform your TypeScript into JavaScript. And TypeScript adds an extra layer on top of your JavaScript application. So maybe for people that join the team that never use TypeScript, or for junior developer with like no experience, this might be a bit like a steeper learning curve. But I would say if you have to maintain and a big project in the longer run, having like a type checking system is really beneficial. If you have to write a really simple MVP or prototype, maybe it's too much, but that's my take on it. And that's all from me. Any question, guys? No, I'm gonna hand over to you, Ilesh.
Yeah, thank you. Thanks, Alberto. Really good presentation.
So yeah, we've got the buzzwords in our title, so we were kept till last. So welcome to our talk, rebuilding our front ends with a single library. So brilliant, the clicker works. So bit of intro about our talk. We're going to chat about us. We're going to chat about our CMS situation, chat about integrating React and TypeScript with our headless CMS. Spoiler alert, it's Kontent. That's why we're such good friends with Ilesh. And chat about modeling our content, and then a few extra things that we missed out from the agenda because we built that first and then built the slides next. So, a bit about us. I'm Harry. I'm the lead web developer for Elanco, so I do web stuff. If the glasses and the beard didn't give it away, I'm a bit of a coffee snob, and in the picture is me doing my best dinosaur impression next to a dinosaur at the zoo. If you can't tell, it's not a real dinosaur, it's Lego.
Nice. My name's Mikael. Formerly a student web developer over at Elanco. It's how I worked with Harry and probably a large amount of the content on this talk. Just gone back to uni to finish off my degree, but that'd be a bit too boring. So I'm also the engineering lead for Google Developer Student Clubs at the University of Portsmouth. Lovely. So mentioned Elanco briefly, and sort of around this time last year, we realized we're in a fairly good state from a web perspective. So we've got JAMstack, nice modern architecture. Spoiler, we're using Kentico Kontent and Next.js. But we realized we weren't really using it as effectively as we could. All the sort of diagrams and pretty pictures the business like to draw had to be implemented by developers in code to build out the front end, which meant that every single one of our sites was made bespoke, despite them all pulling from a common component library, which meant that every single site was built from scratch from code when it probably didn't need to be. And when any of those sites needed changes, all of those changes need to be done in code, which, as those of you familiar would assume, there's a lot of time involved in there. Something else might take priority, which means that whilst that one content editor really wants a certain block to be in a different place on the page, they can't do that for another 2-4 weeks because the developers are busy doing something else. Obviously, developers have to write code, that takes effort. And sadly, it took a lot of spaghetti because a lot of these sites were built using hard-coded templates. We'd pull data out from the CMS and try and put it into a React template, but probably not in the most efficient manner. So realistically, we sat down and said, how can we do this better? For a little bit of background, this is a snippet from one of our sites before the changes. So for those of you that haven't used Next before, get server-side props is how we load data from the CMS into the actual React template. This happens every request. So you can see sort of just going through the code block. We pull from the delivery client everything that's on the page. We pull out the header data, footer data, any other page data, the locale. Then we might have some components in there. So you've got a page banner, there's breadcrumbs. And you can see this is a lot of mess. There's a lot of optional chaining in there, pulling from index 0. It's like spaghetti. And when you actually put it in the React template, it doesn't get too much better. As you can see, it's all fixed. You're sort of randomly throwing data where it fits. And whilst this might work, it's prone to a lot of error and takes a lot of time, which wasn't really the best for our developers.
And that's my cue. So we thought, you know what, we could model this better. We could take some inspiration from TypeScript and we could build a few interfaces, build a nice library around this and work from the bottom up. So historically, we'd go straight in on the CMS, be like, this is what I want it to look like, go into the code base and have a good cry as we sprinted away. So we wanted to add some extra stuff like make the data from the CMS a bit easier to work with, but using TypeScript make it a bit more predictable as well. So nothing like last edited with every single content type, or we don't really care about who made some kind of edit for every single bit of content. So we thought, get rid of the fluff. We also wanted to, because we're developers, we are intrinsically lazy. So we wanted to build this such that we could let the business decide what was on the page without having to wait for like a 2-week sprint. So we're going to take you through our journey from spaghetti all the way up to some beautiful crisp macaroni.
So about Christmas time, Harry and I were working a little bit longer, probably not taking as much holiday as we should. But we had about a week before Christmas, and we knew that we wanted to make a sort of small internal demo site. So a website like the rest of ours, but one that we could just throw any new analytics technology on, and didn't really sort of have much resource to put into that. The content structure actually had to change without developer input. The people that wanted to test stuff on that site weren't developers, so they couldn't go into the code to change this. And obviously, going back to that prioritization point, we had other things we needed to work on. So this site really needed to be independent. So we sat down in about 3 to 4 working days of Harry and I going back and forth, throwing terrible ideas at each other. We eventually come up with one that was good out of all of them. And that was this sort of new blocky content model. So sort of familiar with sort of the Lego brick approach, where your site is just built out of these little blocks that you can piece together to actually go out and make a site. Almost reattaching the head. So you might have like your WordPresses, your Squarespaces that you can put in the blocks of a page, but this using slightly better code than those, while still giving content editors the freedom they need. From the code sort of perspective, we had a standard type to inherit blocks from. Getting that type safety from TypeScript was absolutely critical, and not something that was being done at Elanco currently. And again, default components for people to pull from, rather than sort of relying on sort of developers to build everything from scratch. So in terms of the content model itself, I've seen a few talks where they differentiate between what an article looks like, what a blog looks like, and other pages. We decided it actually be a better model for at least our use case to have just one page type in the CMS that everything else builds upon. So you have this overall sort of page bucket, and the page holds sort of two main things. These are your blocks, so actually what appears on the site, and any metadata. So typically what happens in the head of the document, which if I carry on, metadata being things like your SEO tags, as well as your config for Google Analytics. Whereas your blocks, like I said, the visual elements of the page, any markdown, sort of a slider with some images on the page, any hero elements, you might have some breadcrumb for navigation, cards, just anything visual, almost mapping to our component library to give content editors the flexibility they need, whilst we've still got some level of safety over the code.
So, slide 11, we're finally showing a bit of TypeScript. I appreciate that the stuff on the left is actually probably a bit dated, probably not a good example, but hopefully it gives you a fairly good idea. This is something that I chucked together before, so I don't think it totally represents what we do, and there's some bad practices there anyway. But our first goal, make the API response bit nicer to work with. So looking at my notes, you can see that basically what we want to do is go to the CMS and only get really what we can map to our default set type. So a string for like text and rich text, you know, puts the M in JAMstack, a number, a multiple choice element, or a reference to itself. So, you know, if you're thinking blocks, you might think, oh, but you can only have one thing per row. Not if you have a row type where you can put stuff next to each other. This means that our get server side props that Michael spoke about earlier is a lot easier to work with. We just say get the stuff based on the slug from the CMS, make it nicer, throw it in through props. Again, face value, it makes it easy, but if we think back to our component, perhaps, you know, we're also going to want to map this, make it a bit easier for you know, in the code side. So we came up with a map really, which is take our code name for our element from the content management system, literally just map it to some other component. So our product card would map to a product thing. We'd know what those types are. We'd generate those types based on some content model as code. So we've got a map. We have a map component. Again, appreciate it's a bit simplified, but looking at the earlier talks, you can see how TypeScript really lends itself to this, because coming in as a new developer, you do get a strong feel for like the structure of the site.
Yeah, so as content editor going into this, we really want to make this as simple as possible. Content models of the past were a lot stricter, possibly a lot more confusing for the content editor. This would be the long input form where you need to locate the brand bar within it, the exact text element that you wanted to put in, and slowly piece it together. Whereas with our new model, we want it to be almost a blank canvas to work on. And then you use these sort of Lego bricks to actually build up your page to as big or as small as you want it. So on the right-hand side, you can see the page blocks on a site. And these are in order of what they'd appear on a site. So you've got a hero element at the top, one of our little brand bars, which is sort of a strip of color that sort of merges with the header, some breadcrumbs for navigation, a rich text component, and then also a layout row. This was a neat little trick that we implemented sort of halfway through development to allow elements to appear next to each other in a row. For mobile friendliness, they'd obviously resize, and we have a few other layouts that we sort of not mentioned today, but it sort of gives the content editor a little bit of freedom of how it appears rather than just going from top to bottom, while still keeping that sort of overall simplicity. And then when it comes to other sites, we knew that sort of our first site that we put this on was campaign.elanco.com. This was sort of like a blank canvas site again, where the overall site doesn't have any hierarchy. If you hit that URL exactly, you'll just get hit by 404. But it's a place for marketing to go in, and if they need to have a brand activation or they just need to get some content out on the web, they can just host it on their own little URL on that site. So we've had some amazing launches there, worked with some people in marketing. We knew it worked, but we wanted to package up all of those learnings into a model that can actually be used not just on campaign.elanco, not just that demo site, but actually in a few other places. But as well as that, we also had to consider how we were updating our content model. Initially, we weren't doing that in code, but we actually put together a CLI based off the content CLI that allows us to update our content model from code to make sure that no matter which CMS project we were using, they were all in sync, they were all versioned, and they were actually using the correct content types across everything without a content editor or a developer having to manually update that. At the code side, we actually published and sort of extracted this mapper, this terser, into its own React library that we then published on an internal NPM repo, purely so we can version control it and actually efficiently roll this out across quite a large number of sites now. And in terms of sort of overall outcomes from this entire process, pages, page structure are all entirely handled by the business now. Developers don't need to get involved in order to create new pages, which is a huge cost saving. Again, from a 2-week sprint to actually change blocks on a page, this is only a day. It says a day on here, but probably a matter of hours, if not minutes, for content editors go in, put something new on the page, publish it, and get it live. This model, because of Next.js, allows us to publish these sites statically, which is a matter of £5 a year, $5 a year, versus hundreds, if not thousands, of site costs per year previously. And that also means that when it comes to internal sites, the sort of cost benefit analysis on that is a lot better. If you want to spin up a developer portal or a site for our internal student program, we were able to do that at very low cost and actually low time, because we actually put a lot of thought into how developers interact with this and not just content editors. And it makes it a code base that developers actually want to interact with.
So, if you like our talk, we're hiring. Send me an email, hit me up on LinkedIn. We're after web guys, TPOs, senior web guys, backend guys. We want a lot. We want the stack. Come shoot me a message. Come chat to me on LinkedIn. If you want to learn more, again, just shoot me a message. I'm happy to jump on a call. We can pair program. We can do whatever. We can grab coffee. Buy me a coffee. So yeah, here's where to find us, and thank you very much for your time.
Thank you very much.
Brilliant, thank you. Are there any questions for them, or they're just been added to the chat, which is great? Who's offering more, MMT or Elanco? Well, come speak to me first, and then I'll tell you. Okay, that's brilliant. Thanks, guys. Jarryd, you okay now?
Yeah, I've bitten the bullet and I've installed Teams, the filth on my MacBook, so can feel the infection of Microsoft harvesting my data already. Cool, let's see if this works. I can now see that I can share things. Oh, you're joking. Would like to control computer using accessibility features. Oh, good Lord. It's happening again. I guarantee this is going to ask me to close and reopen Teams, at which point I'm going to lose my marbles.
Hi, when it asks you to close it, if you're on Mac, you don't have to. It's lying to you.
Who is that? Because I need a bit of your wisdom in my life.
Mm-hmm.
Okay.
I'm Jack. I'm one of the lecturers who taught Harry and might be teaching Michael.
Nice. Okay. Well, good to meet you, Jack. Thank you for that. I'm assuming everyone can see my screen. I'm sort of blindly, I've got my slide up. It says pushing the boundary of your application.
Yeah, we can see it.
We can see it.
Yes, it's happening, everyone. It's finally happening. Okay. Cool. Well, thank you so much, Ilesh, for inviting me to talk. I'm going to skip the introduction about me. I'm less important, but I will say I work at Couchbase, and everything I say you should take with a pinch of salt. I'm no longer an engineer. I'm an engineering manager. So what do I know, right? I don't really write code on a day-to-day basis. So everything I'm about to talk about could be out of date. I don't know. But there are principles here that I'm hoping you'll be able to take away. So yeah, like I said, work at Couchbase. We've recently gone public, which is why I'm wearing my cap. Some swag arrived today, so there we go. From this talk, what you can expect is absolutely nothing groundbreaking. I'm not going to share anything new or anything that's not already been covered or anything really that's not already out there. You could go and Google and find everything I'm going to talk about. I love a good meme, so you can expect some really strong memes from this. I'm going to give you some really bad code examples. I'm going to have lots of stock imagery, as you've already seen, probably some incorrectly attributed quotes. And I'm definitely going to try and avoid any live code if I can possibly help it. I recently found this quote, and I thought this was incredibly helpful, from Abraham Lincoln. He said, if I had 4 hours to chop down a tree, I would spend the first 3 hours creating the JIRA ticket. And I think that speaks to the heart of everything we do as software engineers, which is we take our time to plan, we really think through our data contracts, to really think about what we're going to build, and we put that all in a JIRA ticket rather than writing the code. The other quote that I found was really helpful from him was this one. Obviously, don't trust everything you read on the internet. Okay, so perhaps it would be helpful to throw out some definitions, and the most useful definition is defining what is the boundary of our application. And for the most part, there are these 5 examples that I could think of, and there's probably many more, but it's effectively anything that interacts with the code that we write that has an impact or an effect on our application. And so the top one there, the network, is very broad. Are we talking about the internet? Are we talking about Wi-Fi? Are we talking about sort of Bluetooth connections? So like maybe you're like me wondering, okay, what does that mean? Which protocol are you talking about? Well, specifically, I want to talk about APIs and the APIs that our websites and our web applications interact with. And the question at Couchbase that we found ourselves asking on a regular basis is, how do we guarantee that our application doesn't crash or provide a bad user experience because of an invalid data type? And it turns out, as I did my pilgrimage through the internet and looked for answers, there is a tribe of people who are themselves software engineers, but of a very different nature. And these people have weird practices and write code very differently. And they call themselves functional programmers, and as best I could understand, this is their symbol. So this is the symbol of the functional programming people. And having spent some time with them, they also have some incredibly strange jargon, things like functors and monads and monoids, and I do not understand any of these things. There was no translator available when I met with them, so I can't help you there. But there is this jargon buster website that they've provided us mere mortals with to understand the language that they're speaking. And it turns out that actually in functional programming, there's another broader study called category theory. And as I've shown you there, you can Google that. Category theory for programmers. Phenomenal speaker by a guy called Bartosz Milewski, probably butchered the pronunciation of that. But he talks about category theory, and effectively all category theory is the theory of how we categorize things. And I know that sounds incredibly trivial and dumbed down, but in effect that really helps us as programmers, because category theory also studies the relationship between things and as a function of each other. So I won't go too much into that. Definitely look it up. Go and do your Googling and your YouTubing, and other search engines are available. Look up category theory, which informs functional programming, which is what I really want to explore, which is then the next logical step from that is type-driven development. In functional programming, we have pure functions and all of those things that that have slipped into our vernacular as React developers, or perhaps anyone who writes like a single page application, we're used to these terms of immutability and pure functions, and so which is why I believe TypeScript is gained so much popularity. TypeScript is itself it's a superset of JavaScript, which is a functional programming language. If you weren't aware, functions are first-class citizens. You can pass them around as values. That's all that means. So highly recommend this talk that is called Not Your Mother's TDD. Don't know why, but that's what it's called, and it's all about type-driven development. Again, I've got the slides here. I can send them to Ilesh, or you can request them from me at the end, and I'll send them over. Some really helpful links there, but definitely check out that YouTube video. Walks through all the sorts of different types that we have in TypeScript and ways we can do it. So you're probably asking, how does that help me? Like, I just want to write TypeScript. So, you're talking about functional programming and category theory and type-driven development. And so what does that all mean? And so how does it help me? Well, in true presentation fashion, I'm going to attempt a live code example. And I went through this with James Asprey, who's on the call. I went through it with him earlier, and I completely butchered it. So I can't guarantee this is going to work. I'm assuming you can see this. I've just highlighted some code. I'm assuming you can see that.
Yep.
Give me a shout if you can. Yeah. Oh, actually, I've just realized you probably need to see the web browser as well, which will help. So give me just a second. I think it's this one. Presenting. Cool. I do apologize to those of you on smaller screens. I do have a slightly wider than usual monitor. So I'm hoping you can see that. We've got the MMT TypeScript Meetup app on the right, code on the left. Give me a shout.
Yeah, that's okay.
Yeah, I can see it. Very small.
Oh, listen to all this interaction. It's like we're humans. Sip of the old whiskey before we carry on. Okay. So I'm going to shoot through this, and like I say, I butchered it earlier, but I'll really try my best. In practice, when we think about types and type-driven development, the idea behind this is that we model our application and the data in our application purely on the basis of types and how those types interact with each other, otherwise known as functions. So very quickly, let's say we have this app. And as an example, we want to render a list of users and then click on it and have a modal pop up with the user details. Okay, fairly trivial, not much interaction. And our illustrious lead developer has given us some helpful data here, which is incredibly unhelpful. And so what we want to do from here is probably get some data from an endpoint. As you can see here, I've got this basic endpoint set up. And because we're modern, we use a hook. And at some point, let's say we want to introduce some types. Okay, so if I were to run this now, if I get rid of that and have users use users, I'm really hoping IntelliSense will kick in. It won't. Helpful. I'll just have to import it. Users from. Thanks for the clearing of the throat there, Ilesh. I hope that's okay for you. I hope that throat is hella clear. And then we'll just delete that. So then, yeah, sure. Okay, so we've got this users.map, and we can see that there's some pretty funky stuff going on here. The hook isn't returning what we expected to. It's wrapped in a promise, and there's an any there, which is probably unhelpful because we can't identify what the data is, and this hook's effectively useless. So what we're going to do as really good software engineers for the front end is we're going to do the right thing, and we're going to install a library called React Query. If you've not used React Query, I highly recommend it. Check it out. It's by a developer called Tanner Lindsay. it has so much out the box. It provides exponential back off, as in it retries 3 times and then fails. It provides auto polling. It provides a cache. It's an incredibly powerful library, all wrapped up in this one hook. And so, okay, now we've got our hook over here, and we've got our application, and you can see here we're getting some data, and oh, I probably need to start the server. Okay, yes. So we've got this error. Data.data.map is not a function, and so that's because, you know, this is effectively broken, right? Like we're not doing any sort of data checking, and what I want to do here is when I get a response, I want to pull the data type off of that response. Okay. Still not quite working as I expected. Undefined. And so the point I'm trying to make here is that there's a load of type checking that we're not doing. We're just assuming that the data is coming back in the shape that we expect it to. And so the next iteration that we want to do as engineers, is to do this, right? So we've got our data. Now we've got some from React Query. We've got some loading and error states, and we can do that over here. Sorry, did someone want to say something there? No? Okay. And what React Query allows us to do is pass in a type annotation, which we can say is that or an error. And now if we come back over here, we should be able to see that we have a user or an error, right? And so, oops, sorry, I missed a. So now TypeScript will tell us in a minute that, like I said, I probably butchered it. Effectively, if you look at it, right, so ignoring the error, TypeScript will tell us that this, okay, yeah, cool, you've given me an array of users, I can now use this in the UI, and away we go, right? But there again, we end up with a problem that we've not actually validated that the types are as we expect them to be. And so there's another kind of iteration that we have to do here, and I'm going to race through this because I don't want to talk forever, and I'm probably boring you with the code examples. But there's a results property on the response that comes back, and so you see I've kind of got the data, and I've kind of in the endpoint I've got the res.data.results, because you can see in the example object there's a results object on the response, and blah 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 blah, and I'm kind of shooting through. And so now I've got a fully functional application, right? I can select a user and they pop up, and I can even start to get rid of some of these checks here, because I've asserted that the data coming back on the hook is a user type. And maybe it would be helpful to talk about what a user type is. Well, there you go. That's what I've told TypeScript I'm going to use. But the problem with this example, and this is really where I'm trying to land, the problem here is that in no way have I guarded the boundary of my application. I've not in it. I'm effectively relying on the API. And just as an example, I could. I'm hoping this will work as an example. I didn't actually test this earlier. I'm going to need to clear the cache. So when this makes a request, you can see that this blows up. And the reason for that is because the data that's coming back, you can see it's missing the name. So the property on the results, which I'm using here, is missing the name value. And so TypeScript is satisfied. You can see over here it's compiled successfully. TypeScript is satisfied. You know, the application is saying, yeah, you've told me that the data is what I expect. And then when we run it, we get this massive runtime error, which blows up, and it's a horrible experience for our users, right? But that's, you know, we can do better than that because we're professionals and we know exactly what we're doing. We've done all this stuff before. And so fast forwarding a few iterations of the application, and this is where I get to. Let me just stop and start the server again without the bad data. I'll shoot through this, and I do apologize. It looks very convoluted, and that's largely because it is. I didn't clear this. What we have to do is create what's called a type guard, and this is for anyone who's done any sort of JavaScript programming. This is effectively just an exhaustive property check on every object, and so you can see I start off by asserting that the data that comes in, I get the data, and because it's Axios, it's got a data property on the response. I then pass that response through to this parser, which does the check on the data. I will take questions, I promise. So I'm shooting through this because I know I've spoken for too long already. I run a validation on the data, throw an invalid response error with 3 R's because I can spell, or I return the data. And at this point here, you can see my IntelliSense is telling me that the data that's unknown from Axios is coming back with a user response. Now, what's a user response, you ask? Well, it's just a type that I've defined here. But what I've done in this validation is I've asserted that the fields on the object are exactly as I expect them to be. So, you know, I've got a name in the response. I have I've got a results property on the data object. And once I've done that, this should work. Okay, so at this point now, I've got my validation, and yes, there's a whole lot more I need to do, okay, because I've told TypeScript that there's going to be a user response, and that needs a user object, and so there's still testing to do, right? So let me just be very clear that our type-driven development still relies very heavily on testing. I need to test that this validation actually does what I expect it to do. But in effect, if I were to then return some bad data, we should see that my type guard will cause this to fail. And you can see here, it's got the invalid, it's going to be too small, invalid response error, failed to pass from API. And that is exactly where I'm catching unexpected data. It's this line here. It's where I'm catching unexpected data at the boundary of my application. So before it even gets to my users, I've said that this field is not an expected type. It doesn't have what I want to use. There's something not right here. And so I'm going to error. And you know, we can do a better job. We can check if it's a field that we're sort of expecting or not expecting. You know, we can do different things. But in effect, what I've done at the boundary of my application, at the request point when I'm interacting with the API, this parser is saying the data needs to be what I expect it to be, or not. In which case, I will throw an error. I hope that's helpful. I've shot through that. I've got a couple more slides. Sorry, Ilesh, I know I'm taking up some time here. Where is my browser? Where has it gone? It's gone. It's gone so far away from me. There we go. So I hope that's helpful. Can you see the exhibit meme?
Yep.
Cool. So in summary, learn and use category theory. It's incredibly helpful. It's a very broad theory on how objects interact with each other. Make the network boundary solid. So in your applications, catch things at the boundary, parse it, use type guards, which assert that a data is as we expect it to be, and then test your type guards to make sure that they do what they should be doing, because the last thing you need is an unhelpful type guard. And this is really what I wanted to say in this talk. The boundary of your application isn't actually anything to do with the code. The boundary of your application is the business problem that you're solving. The boundaries are in your companies, your teams, and in your personal lives. And so my encouragement to my team that I lead and to everybody on this call is to push the boundaries of what you believe is possible, and to push back on things that you believe shouldn't be done. I would love it if we had a generation of developers who came through who put users first and who did the right thing every time, and every time it mattered. And so my encouragement to you, and the one takeaway, if you've learned nothing else, is to push the boundaries of the problems that you solve. I always tell my team this, that nobody pays you to write code. That's simply not true. People pay you to solve a problem, and we're so fortunate that we work in an industry that allows us to solve problems that in a really fun and interesting way. And as a bonus, try Elm. It's a functional programming language written specifically for front-end developers. I'm sure you'll learn a heck of a lot. It's made me a better programmer, a better engineer, and I'm not going to go as far as to say it's made me a better person, but hey, who knows, maybe it will. So there we go. Thank you very much. Any questions, by the way? I'll do a live Q&A rather than a written Q&A. I'm aware I rattled through all of that, so please ask me some questions. I love a good question. Waiting. I was told by a psychologist that it takes people 20 seconds to think of a question when asked. Not because I was seeing a psychologist, it just happens to be a friend, but please do ask any questions. James Asprey, if you don't ask me a question, you and I are going to have a hard talking to tomorrow.
This is Jack. May I?
Oh, hi, Jack. Yeah, go ahead.
I have put it in chat. I don't know if you noticed. I was looking at type guards around receiving JSON data. And what I saw is if you have the TypeScript interfaces, you can generate JSON schemas from those. And I found that that's much easier to maintain, quite obviously, than your own handmade type guards. Have you looked into those by any chance?
I haven't, actually. That's incredibly helpful. Is that on the TypeScript documentation?
No. Sadly, it's not a feature of TypeScript yet. It just might be. It would be a natural feature. But I have only seen it in various projects. I put a URL in the chat a while back. If you Google generating JSON schema from TypeScript, you will find the same projects that I have. There are a few projects looking into it. They might have various limitations, but certainly I think that generating type guards from TypeScript interfaces should be automatic. We shouldn't need, unless of course you have extra business logic where some types cannot be described in TypeScript interfaces, but often they can.
That is incredibly helpful. Thank you very much for that. I will definitely look into that. I think at Couchbase we have a lot of logic that the front end handles, but I can see that definitely there being a use case for this. So thank you very much for that. I will I'll put that to our team and we'll look into it. Appreciate that, Jack.
Cheers.
Any other questions? I'm going to push James Asprey. If he doesn't ask me a question, he's going to have a long talking to tomorrow. That one-to-one's going to last hours.
Can you hear me?
Yeah, I can hear you. Yeah, that's right.
Cool. Yes, we've got a question from Trevor here that says, type guarding is, I bet, primarily when you're accepting from an external API that you didn't develop or someone else may modify. Is there any reason you would use it for an internal API?
That's a good question. I think yes, simply because it's a great way to, like, we're all human, right? We all make mistakes as we're developing. I certainly do. I make typos all the time. I miss things, and so if I was writing the back end and the front end, I would almost guarantee that I would make a typo at some point. And the last thing I would want to do is spend hours trying to debug a problem because I'd made a typo, which a type guard, if written really well, I mean, at Couchbase, we've got a incredibly mature type checking system that kind of logs and tells us the exact sort of property that we were expecting, and it wasn't as we expected it. But I mean, it all comes down to trade-offs, right? Like, is it going to take you longer to just fix the API and check it that way, or is it going to take you longer to write the TypeScript, like the type guards? It comes down to trade-offs. Everything we do as engineers is about trade-offs. You know, there's the classic project management triangle. You can have it fast, cheap, or high quality. You got to pick two. That would be my answer. Of course, I'm sure there are people much smarter than me who'd probably tell you something else. Ideally, actually, funny you say that. Ideally, where I want us to get to, I mean, most of all of our backend code is written in Go. And what I would love to do is automate all of that so that the API, as the Go engineers are creating the interfaces and defining the struct types and the data types, that we would have some sort of build running that would automatically generate the TypeScript types and all the type guards and what have you. And much like Jack said, right, the more we can automate and create these, the more we cut out human error. And who knows, maybe in 3 years, GitHub Autopilot will take our jobs and we won't even have to write type guards. Any other questions? How old am I? Oh, well, thank you for asking, whoever that kind person was. I'm 31. Cool, Ilesh, over to you.